and it's going to need to be optional, because otherwise, if you would not provide this optional sign for this function, your customers will be forced to use the onClick every time, but it doesn't make any sense, because you can use button without click handlers. That's perfectly fine. And last but not least, we want to provide some theming support. So let's get some coloring, and we're going to use color variants, right? And this color variant is a type alias of various string literals. So easy. Next step, we need to do this structure, these props. This is also a very common pattern in React. So let's do that. So we have color, we have onClick, and we will project our children here and register our onClick on our button. And last but not least, we need to provide these theming capabilities. So I will create some function, some class, and because color is optional, I need to check if it exists, and then I'm going to render some class from the framework that I'm using under the hood. All right, and let's use this dynamic class right here. Okay, looks good. Let's check it out if it works. So I'm going to import my button. From button. Awesome. It's here. Let's use it. Click. Works. But I'm missing something. All right, I have some mistake. Children React element. Whatever. Let's try to register some onClick. And it's going to be just a function. It's going to Nice, you're smart. Let's see how it's going to work out. So let's say it's primary, and it works. It outputs the content, but that's weird. Yeah, you can use React Node, but that's not a very good pattern, which I can talk later on. But yeah, let's try it out. It's there. Okay. You're smart. You fixed the problem. Right, so here we have button, and of course, because we're in TypeScript, we get all the IntelliSense of the various APIs that we can use immediately without going to docs, which is, again, very, very nice and powerful. So with that, that was stateless component. What about stateful component? Well, again, it's a function which is not pure anymore, it's impure, and it maintains some internal state. So let's implement some stateful component. And we will do, or we will implement, rather say, a counter component, because everyone loves to count stuff. So this counter will return some diff, which will have, again, some styles, which I already prepared. And we're going to use our already implemented button, like this. And we're going to have like thumbs up, thumbs down, just like that. And in the middle, we're going to render some count, right? And how are we going to increment and decrement these values? We need to provide some handlers. So we're going to use handler click, which will use some handler click, which we haven't implemented yet. And this is going to use handler decrement. So let's implement those. So handle increment, oops, and handle decrement. Right, so now the thing is, how are we going to maintain state? Because it's a function, right? And maybe you used to define state with a class. But since React 16.8, we have hooks. So hooks gives us functionality how to hook into React functionality and maintain state or create state within functional components. So we don't have to use classes anymore. So for that, I will use state, which accepts some initial state, as you can see, thanks to the TypeScript. And this returns a tuple. And TypeScript is aware of tuples. So we will get state and set state. And because TypeScript has awesome inference, we already know that state is type of number and set state is some type of callback, right? So we cannot do any typos or because we have the compiler safety in our program. So let's implement our handlers. So we will just use set state, and we're gonna leverage previous snapshot and gonna increment this snapshot by 1. And the same will apply for decrement, but we will do -1. And of course I have to render our state. And let's try our counter. Okay, it's there. Increments, decrements. Nice. So that's a stateful component in React and TypeScript. So another pair of basic patterns are controlled and uncontrolled component. So what is a controlled component? Well, it's basically the counter that I already implemented, right? It maintains some internal state, so it lives its own life. So with that said, I'm gonna hop back to the editor, and I'm gonna go to another example, and I'm gonna copy this counter implementation. Okay, so the question is, what is a controlled component? Well, as the name says, it's controlled by somebody. In the React terms, it's controlled by the parent, right? So the parent implements the state and controls the component by props. So it propagates the values to our counter, and with that, the counter isn't maintaining the state anymore because the parent is in charge of the state. So let's add this API to the counter to make it more flexible for our consumers, right? So how are we going to do that? Well, via props. So what kind of props do we need? Well, the common pattern is to propagate value and some change handler. So let's do that. We're going to have count, type of number, and on change, which is going to be a function that will accept a new value of type of number, and it will return anything. And also we need to make it optional by leveraging map types in TypeScript, because again, we want to provide both APIs, right? Controlled and uncontrolled. If we wouldn't provide this partial, it will error during compile time that you haven't provided that count and onChange handler. Cool. So now I can use this counter in controlled way. So I have count, I'm gonna use root state for it, and onChange, which gonna just again call some callback from the parent, right? So it's there, and it works but doesn't, right? It still changes the internal state. So why is that happening? We don't have any compile errors. Of course, from the type perspective, it's okay, but not from the functional perspective. That's also one of the reasons why you should write tests. By the way, who writes tests in the room? Nice. 70% of the audience, not bad. I don't write this. Just kidding. All right, so what's the next pattern? Well, maybe you saw that what people do, they just reset the state with the props, right? So we can use some use effect and set the state within that effect when the props changes. But that's not a very good pattern and introduces a lot of boilerplate and not very clear code. Instead, what we can do, we can introduce a getter, because it's just a JavaScript. So let's create a getter, get state, and this getter will check if count is defined on props. If it is, then we're gonna use this as our state. Otherwise, we're gonna maintain our internal state for the uncontrolled behavior, right? And also, we need to tweak a little bit our handlers. So I'm gonna check if onChange is defined. If it is defined, then this onChange is gonna be called, but with a new state +1 as previously, right? And I'm gonna exit early right here. And the same needs to be done for a handle decrement. But again, I'm gonna provide -1. And we need to provide a small change in our template. So this state is not the state that we're using all the time. So instead we need to call our get state getter. So now, if I try it out, it works, right? So the state is in sync because my counter isn't doing with state absolutely anything. The parent is in charge. So that's controlled and uncontrolled component. So with that, we covered the two basic patterns in React, stateless stateful and controlled uncontrolled. So you successfully created a pull request with this code, right? And a senior developer will do a review. And he will immediately come to your desk like, hey man. Yeah, what's up? I saw the review. And you know? No what? It's good code, but we are better than this. Yeah, we are? So what should we do? We should extract this code to have some more dry code and cleaner code. You know what I mean? Yeah, I can do that. Awesome. So what does he mean by cleaner code? Well, we have hooks in React. What are those hooks? Well, I tend to name them like it's a controller or reusable controller for your component. So you have detached logic somewhere else. And while React gives us some basic hooks, we can introduce our custom hooks. So let's implement or extract our counter behavior to custom use counter hook. All right. So, how does a custom hook look like? It's just a function, as everything in React. Functions everywhere. And this use counter will return something. Return what? So for that sake, I will go back to my already implemented counter. I'm gonna copy this, because copying is awesome. Thanks God for Stack Overflow, right? And I will paste it right here. And now what I need to do, I will use these props for my hook. So let's hoist them up. And I will use the same props for this new custom hook. And I will just cut all this logic from this component. Put it here. And last but not least, I need to provide a new public interface of my hook, which is gonna be count. And this will call or get state. Then we're gonna have increment. This is just gonna alias or internal handle increment and decrement. Cool. But this doesn't work now, right? So what we need to do, we need to use our custom counter hook. We will pass just the props, and we will destructure all the public API that we have, and we will replace this code with our new APIs. So increment, decrement, and we don't have to care anymore if we are calling some function or whatnot. We are just using the state from our hook. Okay. Let's try if it works. So here is a counter in uncontrolled mode. Cool. And let's try if it's gonna work in controlled mode. So count is gonna be provided by the parent. So root state, and on change will be set root state. All right. Works. That was easy, right? Just encapsulating stuff into a custom hook. So everyone is happy. Senior dev will give you thumbs up, and it's merged. So, next day at the office, you already shipped high quality code, but there is this product manager that will approach you like, hey man, you are so awesome, our clients are awesome, I love this company, you know? But we have a special client and he has special requirements, you know what I mean? I guess so. So that counter that you implemented is so cool, but we need a slight modification. So those buttons needs to be colored, and the count needs to be at the first, because our special client loves have counts at the first position. Yeah, sure. You got it. So how are you gonna approach this? Easy. Just copy the code, right? You will create a new component, just add the colors, stop. That's not dry code, and you basically tightly copy, you introducing tight coupling into the component in some other component, and we have better patterns in React for that. In our case, we can leverage declarative composition. By declarative composition, I mean render prop, or children as a function pattern. So what does it mean? We will have our component, which we're going to declaratively use in our view templates, and it will maintain that logic that we implemented previously, and because everything is React is just a function, so we can project via function, unlike HTML where everything is static, right? So we'll use this children as a function and call this child with our internal API, and then it's upon the consumer of our component how the template is going to look like. So let's implement this pattern. Okay, and for that, I'm going to go to the next example. Render props. Awesome. So we already have some API, right? That's fine. So let's again create our counter, which is going to have some props. And now we need to define the children prop. So let's do that via intersection. And this is going to be a function that's going to return React element. And it's going to be called with some API. In our case, this is how the API should look like. So we're going to have count, type of number. Then we're going to have increment, which is going to be a function, and decrement. So I can do some destructuring magic right here. Because I'm interested only in children, I will just rest the rest of the props. And I'm going to return call of these children. But now I need to provide this API, right? So how am I going to do that? We already implemented custom hook, right? Which I forgot to export, by the way. So let's export it. I'm going to go back to my render prop component. And I can directly use this hook and just give it the rest of the props, and that's it. Super easy, right? So we are building on various Lego chunks to get more flexible APIs. So let's check it out if it's going to work. So here is our counter. And it accepts a function as a children, right? And again, we are in TypeScript, and TypeScript knows about these types. So I get IntelliSense immediately. So it's count, increment, and decrement. And I will go back to the original tightly coupled template. And I will just copy it and return it. And I got no errors. This works, right? It's in uncontrolled mode. But what was the product manager saying? Right, this needs to be up. I need to provide some colors. So this is going to be success. And this is going to be very dangerous to decrement values. Save. Nice. Exactly as the PM wanted, and everyone is happy. Customer, project manager, and my paycheck. And of course, because we are still leveraging the existing functionality, the control mode works as well. So I can provide my root state and my on-change handler. And now again, the single source of truth of state is going to be in the parent. So that works. Very nice. We are almost done. There is one more thing. There is this guy from functional team. Yeah, they like functional programming, so he'll go to our desk like, "Hey man." "Oh no, hi." "You know, I saw that counter that you implemented, and it's great, but we don't like declarative composition." "What do you like?" as you know, we are functional geeks, right? So we need functional composition. So I would like to have an API with that counter so I can compose it within other components. You know what I mean? Yeah, no worries. Another task. Life's hard. So just to refresh your memory, what is a functional composition is basically composing various pure functions into a new extended functionality. Or even if you have used, Redux or GraphQL or Apple client, there is this connect component, which also works in this kind of manner in a functional composition, right? So, and in React terms, it's called highorder component, which is nothing else, just a highorder function. So it's just a function that accepts some component and returns a new component with new superpowers. So to make everyone happy, let's implement our counter behavior like a high-order component. Okay. So let's describe a little bit the use case of that previous engineer from the functional team. So they have some stepper component that doesn't maintain any internal logic, so it's pure, and renders some template, right? So I can use it, and it's like a progress bar, and you can increment and decrement, right? This doesn't work, of course. Even TypeScript is telling me like I'm missing a lot of required properties. So what we need to do, we need to introduce our high-order component called withCounter, which will inject this new behavior to our stateless component. So let's do that. Before we continue, let's take a closer look at this prop API. So we have this count, increment, decrement. That's familiar, right? That's the API of our hook. So we can define some injected props for our high-order component, which are just leveraging already implemented code. So this is some TypeScript meta-programming. And what I'm doing here, I'm getting just the type of useCounter. This will give me the annotation of that function. And then I'm using conditional types built in a TypeScript compiler. In our case, we're using return type. And this return type will infer the return value of that function. And with that, we are producing dry code, and we get injected props with that interface that we wanted. So that's cool. So we are ready to implement our high-order component. So let's do that. So it's going to be called withCounter. And it's going to accept some wrapped component. And internally, we're going to create a new component that's going to have some props as well. And it will return or wrapped component with new behavior. And we have a lot of errors here, obviously, because we are in TypeScript. So what we need to do, we need to annotate this component. So what type of component is this going to be? It's going to be a JSX element constructor. So that's a type provided by React typings. And it's like function or class component. In our case, it's going to be function. But this type needs a generic props. And to make this component flexible and type aware, we need to introduce generic annotation for the props of this high-order component. And we need to constrain this generic to our already defined injected props, right? And then this type P will flow into this JSX element constructor right here, right? And last but not least, now I need to define some internal props for my inner component. And this is going to be very complicated, because what needs to be done, we need to take this P, all the props that will be implemented by the wrapped component, and we need to subtract all these injected prop keys from the original ones, right? So the outcome will be smaller API which is already implemented inside of this component. So how can we do that? Well, we can use map types from TypeScript. So we will omit from P all keys of our injected props, right? And then what I can do, I can just spread the props. But I get still some errors. Type pick blah blah blah. It's not very clear, like the error message, but you will get used to it eventually. And what is this missing? Of course, the component isn't accepting any count, increment, or decrement. So how are we gonna introduce this functionality? Well, we can reach out to previous implementation, in our case, counter as a render prop, and we can use that. So let's take a render, or counter, and it accepts a function as a child, right, with some injected props API. And here we're gonna return our component, and we're just gonna spread those injected props. And I get some error here. So with counter, all right, I need to put it in the square brackets. Oh no. Of course, mistakes of live coding. I forgot to export this counter, obviously. You see? If this would be vanilla JavaScript, I will be stuck on the stage, and that will be very embarrassing, right? So, now this is okay, but this yells at us. There is a lack of function of capability in TypeScript compiler when you want to spread and join generics. So we need to explicitly annotate this injected prop spread as a P to tell the compiler that, hey man, I really know what I'm doing, so no worries about that. Okay, and now I can use my counter stepper. No compile errors. Let's take a look if it's gonna work. Nice. It works. Even we had this color API, right? So we can use that as well. And again, thanks to TypeScript, I got all that IntelliSense, so it's gonna be success. And it's rendered in a green color, so that works. And let's say we need to add some last functionality, because incrementing by 1 is not very effective. So let's say we want to add some extended behavior by providing a stepper, right? So what's the incrementation value of the count inside the component? So this is definition, super easy. And we need to extend our inner props by type intersection. So now inner props is gonna have this step as well. And what we need to do, we need to again do some destructuring from the props, and we're gonna check just the step, and I'm gonna just rest the pass-through props like that. Now let's use pass-through props here, and within this function call I need to create or introduce some new logic. So let's call this extended API, and we're gonna do some ternary. So if step is defined on the props, we're gonna use the same API that we used previously, but we're gonna twig a little bit the count. So it's gonna be the original count, but multiplied by our step. Else, we're gonna just use injected props. And now let's change injected props to extended API. All right, no compilation errors. And let's try if it's gonna work in the code. So now I have here the new API, step, which is optional, of course. And I wanna step got multiplied by 10. Okay? Works. Awesome. So our job is finished here. So in the end of the day, everyone is happy. Our senior developer, our product manager, and our functional developer. By introducing all these flexible patterns provided by React and basically JavaScript. So let's recap what we learned today. So we started with the basic building blocks of React component patterns, which are stateless, stateful component, and controlled, uncontrolled component. We took those and introduced hooks to get some dry and clean code with reusable logic. By leveraging our custom hook, we introduced render pro pattern. And by leveraging render pro pattern, we introduced high order component. And this is very flexible trio that is very easily implemented, and you can provide various kinds of flexible APIs for your component consumers. If you want to learn more, definitely check my article about TypeScript pro tips patterns with or without React. So it's also for Angular or Vue folks. You don't have to be afraid. Also make sure to check my other blog posts. I publish various of these, again on my Medium profile. And all these demos will be published on GitHub, so it's going to be open source, of course, so you can play with it a little bit, because it was a lot of content. And with that said, make sure to follow me. That's my Twitter handler. And thanks for having me. Enjoy the lunch. And